Hello and welcome. I'd like to take a few minutes here to review the process of determining the first usable host, the last usable host, broadcast address, and the network address when given an IP address and a subnet mask. We know that there are two parts of a network address, of an IPv4 address. First, we have the address itself, something like a 192.168.200.150, and we can go up to 254 on these, or 255 on these, the 8 bits when we add them up, has an address itself as well as a subnet mask. The subnet mask would look something like 255.255.255.0, which, as you know, is the subnet mask of a Class C network. So this is one that we'll look at here for just a minute. The bits, the 255 represents the ones. Ones in the subnet mask represent network address, whereas zeros in the subnet mask represent host bits. A couple of other rules. The network address is the one where the host bits are all 0. So the network address would be all zeros in the portion of the network where the subnet mask is zeros. We'll look at that on a spreadsheet here just in a second. The broadcast address is the address where the host bits are all 1. Notice that we're only concerned with host bits here to define the broadcast and the network address. The broadcast address is the address that sends the information to all of the computers on a particular network. The first usable host address is the network address, the one that's all zeros plus 1. The last usable host address is the broadcast address, which is all ones minus 1. So those two manipulations, those two definitions, rules will tell us what's the first, last, the 4 actually, the first, the last, the network address, and the broadcast address. To do that, I'd like to look at a couple of problems in a spreadsheet. So if we take this spreadsheet here, and let's take 172.16.24.57 with a 255.255.255.0 subnet mask. 172, as we go through this thing to get to 172, will be a 1 and a 128, which leaves us somewhere around 50, right? Okay, the 172, let's just look at this thing. If we put a 1 in the second bit, would be a 192. When we added them up, that would be too many. So we'll put a 0 in here. A 1 in the 32, we get 60, which we now know we need 12 in order to get there. A 1 and a 4 should get us to that. 16, pretty straightforward, a 1 in the 16 placeholder. The 24, not a 1 there, would it? A 0, we're going to go down to 16 plus 8. A 1 in the 16 and a 1 in the 8 will give us the 24, zeros and everything else. And then to get to the 57, 0, 0, a 1 in the 32. And if we put a 1 in the 16, we're 48, going for 57. So now we need 9, a 1, 56, 0, 0, 1. So we've now written our network address 172.16.24.57 in binary. The subnet mask 255.255.255.0 is already in here. And notice that the colors change when we go from network portion to host portion. If you're not using something like this, I would recommend that when you do this, you draw a line between the network portion and the host portion so that you can distinguish what's there. The ANDing process we need to go through to get our address, and we've already defined the network address. The network address, the host bits are all 0, and in this case the host bits are already all 0. So let's go through and AND this thing. 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. 1 and 1 is 1. 0, 0. We'll just go through here. We got the 16. When we do the ANDing process, well, actually I just messed that up, didn't I? 1 and 0 is going to be 0. So when we go through the ANDing process, 1 and 1, if they're likes, they're the same. If they're unlikes, they're always going to be 0. So we have now determined that the network address is 172.16.24.0. Guess I was getting a little ahead of myself. What we can do now is just bring down all of the ANDing that we've done, because in the area for the network portion is not really going to change, because we're manipulating the host addresses, not the network addresses. So when we go in here, the broadcast address, let me get on the correct line. The broadcast address is the one where the host bits are all 1. So we put all of our 1s in here. We now have the broadcast address is 172.16.24.255. The first usable host address is the network address, which is the all zeros here plus 1. So our first usable address would be 172.16.24.1. Our last usable address is going to be 172.16.24.1 less than the broadcast address. The broadcast address is all 1s here. We just simply put a 0 in the last bit and 1s in all of the other bits, and that should give us 1 minus the broadcast address, which in this case will be 172.16.24.254. So we've determined, based from writing the IP address and the subnet mask in binary, what the network address is. The network address, host bits are all 0s. The broadcast address where the host bits are all 1. The first usable address where the host bits are 1 plus the network address. And the last usable where the host bits are 1 less than the broadcast network. I'd like to do a second one where the bits wind up to be a little bit different. I've already written the IP address 208.145.201.170 in binary. I have not written yet the subnet mask 255.255.255.240. The current one is 255.255.255.0. So if I now change the subnet mask 192.224.240, I have subnetted this thing by breaking it down into more networks, fewer hosts per network. I have 4 bits available for subnet ID and 4 bits available for hosts. Using the 2 to the n, we might as well do a little bit of review here. The 2 to the n minus 2 with 4 bits, 2, 4, 8, 16 minus 2, which would give us 4 usable hosts on each of the usable networks. Same thing on the subnet ID. We have 4 bits, 2, 4, 8, 16 minus 2, because we can't use the all zeros and we can't use the all ones, 14 usable subnets. We go through this thing. So in the process of determining the network address, we'll go through the ANDing process again. 1 and 1 is 1. 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. 0. 1 and 0 0. 1 and 0 0. 1 and 0 0. 1 and 1 is 1. 1 and 0 is 0. 1 and 0 is 0. 1 and 1 is 1. Again, Boolean algebra. 0 0 0 1, and I keep looking back to be sure that I'm getting the right address. 208.145 1 1 0 0 1 0 0 1 201. Now in this case, We want to determine the network address. The network address, by definition, is where the host bits are all 0. So this is still network portion. So we're going to continue ANDing the 1, and 1 is 1, 0, 1, 0. And now we'll put zeros in the host bits to define the network portion. So our network address is 208.145.201.160. Bring down all of our other calculation. Is not going to change the network portion because, again, we're still manipulating, changing the host portion of the address, because in each of these down here, we're talking about host bits. So I can still bring down all of these. By definition, the broadcast address is where the host bits are all 1. So we add that, we're going to have a broadcast address of 208.145.201.175. The first usable address is 1 plus the network address. Network address up here, all zeros. We add 1 to it. We're going to get 208.145.201.161. The last usable address is the broadcast address minus 1, which gives us 208.145.201.174. So by using this process, and again, the binary is the thing that's going to work 100% of the time, we can find the network address, the one where the host bits, regardless of how long the subnet mask is, where the host bits are all zeros. The broadcast address is where the host bits are all 1s. The first usable address is where the host bits are 1 plus the network address. And the last usable address is where the address is 1 less than the broadcast address. Simply by putting a 0 in the last bit of the hosts will give us the last usable network address. That's all that there is to it. This is one of the things that just requires some practice in order to do it. All of the problems that you'll work in this, all the subnetting problems, are all the same problem. They're all the same process. It's a matter of writing it in binary and defining what you actually need. With that, thank you for watching, and I hope this has been useful.